Hey you guys, this is Professor Vitt. I'm just going to walk you through the mock exam here. So, there are going to be 4 types of problems on the exam. The first kind are going to be translations, and they are located here at this link. You click on that link and it'll send you to the Nightmare Before Christmas link. You can also get that through the class's Moodle page. Okay, now there are 3 remaining problem types, but really and truly they all follow the same procedure. They're just different what you do at the end. So I'm going to take them in turn. I can't do them on this video. I have to actually write them out on my little cell phone. So we're going to clip to that right now. Sweet. Oops. All right, there we go. Looking good. How does it look? Okay, here we go. Now this is going to be a little bit of time, you guys. Okay, you guys, this is Professor Vitt. I'm going to cover number 6. Remember, this is on the mock exam number 2. So this is mock exam number 2, problem number 6. I've reviewed the instructions already, so I'm going to go ahead and show you. Remember, all of these truth tables are always the same. This is the most basic version of the truth table, and it's the first set that you'll get on the exam. So, we're told that A, B, and C are going to be true, and that X, Y, and Z are going to be false. So, our first step is to take the true values and go ahead and plug them into our A's, B's, and C's within the original statement. I did that on purpose. So, there's my C, that's going to be true. Here's my B, that's going to be true, okay? And then the next step is to fill in any of the remaining X, Y, Z's with their values. So X is false, and Z right here is false. Dun, 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 dun. Now, remember, we're going to evaluate or compute the entire truth value for this statement. So we have to start inside our parentheses first. Remember, it's like, what's in the bag? What's in the bag, right? What do you have in the bag? We want to go in the bag first, right? So we're going to start inside the parentheses. Remember, our first operator here, doesn't matter whether I start here or here, but this first operator is a horseshoe, and the horseshoe has only one case that we care about. It's when the antecedent is true and the conclusion is false. That's not this case. This is a case where the antecedent is false and the consequent is true, which makes the whole thing true. Okay, so I've done inside the bag here. Now, I'm not done yet because I have to apply the negation. So when you do it, you apply the negation function directly below the function that you're doing. So this entire statement here is true, but we're negating the entire statement, so that's going to make the whole statement false, right? Okay, so here's where we were here, and now I'm going to look over here on this end of the triple bar, and I'm going to say, what are my truth values? True implies false is false. Okay, now, when you take a false statement and you negate it, which is what we're going to do here, remember we've gone inside the bag, and then we're going to apply our negation to a false statement, so that's going to make the statement true. Okay? So remember, it's always the same process, and everything I've done relies upon the initial values of the truth tables that we've explained in class. So, I'm going to continue to work, and I'm going to evaluate this particular operator with these 2 statements. And I go with the very last logical operator that I did. So I'm going to compare a false here to a true here. And remember, the triple bar we call equivalence. And equivalence means that 2 things are the same if they're both true or false at the same time. If one of them is true and one of them is false, then they're not equivalent. Here I have a false statement and a true statement. Can they be equivalent? No, because a false statement says something that's false and a true statement says something that's true. So false implies true is false. In other words, it's not true that they're equivalent. If this said false and false, then we can say, oh, that would be true. Or if this said false and false, then that would be true. But because one value is false and the other one is true, the whole thing is false. Okay, now I'm inside the brackets. This is the very last thing that I've done, this F. So I'm going to apply the negation here to the main operator, which is the equivalence. So remember, do your operation underneath the function. So a false statement that gets negated becomes true. So this is your answer. When you're done with that first set of problems, always make sure that you circle the main operator for me so I know whether the statement is true or false. And that's all you need to do. Maxie, you want to come over and say hi? Okay, no, leave it open. Come on over if you want to say hi.
Hello.
All right. Hello, who are you? What are your names?
Owen.
And?
Max.
Maxie, say hi.
Hi.
Wave, say bye.
Bye.
And whose space is this that I'm using?
Ours.
Yours. Okay, thank you for letting Daddy use it. Okay? All right, you guys go work, okay? Shh, go be quiet. Thank you for helping me. Okay, you guys, so this is problem number 7 on the mock exam. Let's go ahead and just start. Remember, this set of instructions is going to tell us what the value is of our component sentences. So we're going to know whether these little bits are true and false, and then we're going to use this procedure to compute the value of all of it. This video assumes that you remember the initial values of truth tables. So if you don't, make sure that you take a look at those first. So make sure that you know what the truth values are for wedge, and what conditions are these operators, true and false. Okay, so first things first. I know that A, B, and C are going to be true, and X, Y, and Z are going to be false. I'm going to fill in my trues first. So there's going to be a true, there's a B, so that one's true. And there's a B, that one's true. Now, next thing I'm going to do, I'm going to fill in my X, Y, Z's. So there's an X, that's going to be false. Here's a Y, that's going to be false. Now, I want to start inside the bag, right? We've filled in our individual statement letters. Now we want to go inside the bag and see what we can do. So I have a false wedge true, but remember the false is, the wedge is very, very strong, right? Fuerte con la fuerza. It's strong, which means as long as one side of that disjunct is true, the whole thing is true. So there is a true there. Now, I'm going to finish up over here. I've done what's inside the bag, but now I have to apply the negation and do so right out here. If I have a true statement and I negate it, it makes it false. Okay, so I've done this side, right? This value is false. I have dot, which is the conjunct, and then I'm going to evaluate it inside this bag here. So, false wedge true, again, remember the wedge is super strong, so if one side of it is true, then the whole thing is true, so there's a true. Okay, now I have a true statement here and a false statement here, and I'm going to conjoin them. In other words, the conjunction function takes in an F and a T, which will make the whole thing false. Remember, if one side of the dot is false, then the whole thing is false. In order for that to be true, you would have had to have this side true too. So this is true. And that's how you'd solve it. Number 7 is done. Down here. Okay, good.
Hi, this is Owen on the exam.
On the mock exam.
On the mock exam.
And this is problem number 8.
And this is problem number 8.
Go Lakers.
Go Lakers.
Okay, thanks, buddy. Okay, you guys. All right, good. Go ahead. Thanks, bud. Thanks. Okay, so this is going to be problem number 8. You can go ahead, sweetheart. Thanks, buddy. Okay, so this is problem number 8 on the mock exam. Remember, we're given the truth values here of A, B, and C for true, and X, Y, Z for false. So here they're telling you what the value is of these individual statements. Sorry, you guys. What the value is of these individual statements. And thank you to Owen for writing that up on the board for me. Okay, so I'm going to fill in A, B, and C first. So B is going to be true. B again is going to be true. B again is going to be true. And A is going to be true. So let's make sure I wrote it down properly. Excuse me, I'm missing. Not B. Thank you. So this should be a good example for everyone. To double check, right? I mean, here I am making a video of how to do this, and yet I just knew that wasn't right. And I just double checked. Always a good idea to do it, because when you're taking an exam, sometimes that extra pressure, you could copy it down wrong. Okay, so let's go ahead and start inside the bag. Now I know this one is a little bit cramped, but I'm going to work on this individually negated statement letter first. So there's a not, it's a negation, it's going to apply to B, so a negation makes a true statement false. So we have TF. Underneath the wedge, it doesn't matter, right? Because it's still going to be true. So this is true, and I'm putting a little mark right here just so that I know where I am in all this madness, that this was true. Now, I'm going to evaluate this statement letter as true, and I'm going to say true, true under the equivalence means what? So in other words, we're saying if two statements are true at the same time, then they're equivalent, which would be true. So I'm going to put my T right here now. Now I'm going to evaluate this statement, but I'm going to have to apply the negation first, and I already know what my consequent is right here, which is going to be true. It's going to be something arrow true. If I have a true statement and I negate it, it makes it false. So false implies true is true, and this one is true. Now notice one quick thing. Once I knew that this, if you don't see this, don't worry about it. But if you do see it, you're onto something. Once you know that the last half of this is true, you're kind of done, right? Because you know, regardless as to whether the antecedent is true or false, the whole conditional is going to be true. So it could have been false, it could have been true, it doesn't matter, the whole thing is still true. And so there are other ways to do truth tables, which, can you turn that off? Turn it off, please. Okay, just turn it off. There are other ways to do truth tables. Turn it off. Thank you. Okay, thanks. Minor interruptions. There are other ways to do truth tables that incorporate that kind of insight, and they're called indirect truth tables and things like that. Okay, that completes number 8. Okay, you guys, it's Professor Vitt, and this is number 9 on the mock exam, so let's rock and roll. Now, what's important about this group of problems is that they're not giving you the truth values for the individual statements. They're not saying A is going to be true and B is going to be false. They're going to say, determine whether the following statements are tautologist or contradictory or contingent. And what each of those means is, tautologist is it's always true, contradiction is it's always false, and contingent means it can be at least true once and at least false once. So we'll walk through those and explain those concepts as we go along. Okay, so remember I have 2 statement letters here, and I am going to need to tell the truth table under what conditions they're true and false. So I have 2 letters, so 2 letters to the power of 2, so that's going to be 4 rows. So 4 rows, 2 will be true, 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 and 2 will be false, F, F, okay? Now I'm moving from one column to the next, and what that means is, if I was doing 2 true, I'm going to now do 1 true, 1 false. Remember, you cut it in half, true, false. Okay, now I'm going to move over my individual statement letter values across the row. So this is kind of a detail-oriented, boring thing to do. If you feel that way, you're getting the hang of truth tables. So here we go. We have true, true, false, false, true, true, false, false, and true, false, and true, false, true, false. Okay, so all I've done is moved over these individual columns, right? And now I'm going to evaluate the truth values of this entire statement by starting with its parts. So I see parentheses. I want to go in the bag, right? I'm under the conjunction. So what that does mean is there's only one case where it's going to be true. That's when both sides are true. All the other cases are false. Remember, the conjunct is kind of weak. And as long as one side is false, the whole thing's false. Okay, now we're going to finish up over here inside this bag. But remember, we have an individually negated statement letter. We have to do that first before we can finish the bag. So we go inside the bag and we apply the negation. If a true statement has a negation, then it becomes false. And if a false statement gets negated, it becomes true. So we just flip these babies over. Okay, now I'm still inside this bag, right? And I'm going to compare this column to this column, what I just finished. It's the dot, so remember, there's only one case where it's going to be true, when both sides are true. Otherwise, it's going to be false every time. So I found there's a case where they're both true. True, false makes it false. False, false makes it false. False, true makes it false. So now I'm right here. This was my last column. This is my last column. I'm going to compare these two columns that I just finished under the conjunction operator. And if they're both true, then I'll write true. If it's not, I'll leave it blank, and at the end I'll write false. So here we go. True, false is false. False is false. False is false, and false is false, right? So false, false is false, false is false, false, true is false, true, false is false. Notice that this statement is false under every single circumstance. That is called a contradiction. So what you do is you write contradictory. When they're all F, it's contradictory. Now, just for those of you looking ahead, you can actually tell that this is contradictory because there's a B here and there's a not B here, and it's a conjunct. So you're saying A and B and A and not B. So you're kind of, you can see you're saying B and not B, which is essentially true, false. And so it's always going to be a contradiction. Okay, that covers number 9. All right, you guys, we're going to cover problem number 10 kind of quickly here. So remember, I've given you the instructions that I want you to tell me whether this is tautologous, self-contradictory, or contingent. So fill out your rows. We have 2 letters, which means 4 rows. So we divide them 2 true, 2 false. And then as we move over one column, we alternate true, false, true, false, true, false. Now I'm going to move each one of these columns over somewhat quickly. True, true, false, false, true, false, true, false, true, true, false, false, true, true, false, false. Okay, I'm going to work inside the bag. This is just a straight truth table. I'm looking for true, false. When I find it, I write false. Every other value is true. I'm going to work inside this line here. Start with individually negated statement letters first. Negate the B, so it makes a true statement false, true, false, and a false statement true, false to true, false to true. So, we're working with the conjunct. Remember, it's terribly weak. We need both sides to be true in order for the statement to be true, but we don't even have that, so these are all false. And now, this was my last column, and this was my last column. We're going to compare them under the this is the arrow, and I'm very sorry, it can just be the horseshoe. They're equivalent. True implies false, means that the whole thing is false. False antecedent means it's true. True, false makes it false. True, false makes it false. Okay, here's how this works. This one is contingent. Which means you have at least one true and at least one false on that row. Remember, number 9 was all false. So this one here alternates true and false, which makes it contingent. Contingent just means you have at least one true, you have at least one true, and at least, just trying to squeeze in here, at least one false, right? So at least one true, boom. At least one false, boom. And that does it for problem number 10. We're going to skip 11 because it's more of the same, and I'd rather focus on the valid and invalid arguments section 12 through 16. Okay, you guys, let's rock and roll here. This is problem number 12 on the mock exam. And here's what it looks like. I'm asking you to construct a truth table to tell me whether or not this argument is valid. So, you always do it the same way. Remember, like Johnny Cash, you walk the line, boom, 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 boom. And then you take the number of letters that you have. Remember the number of letter types, not tokens. So you have a letter K, and that's it. All right, so the truth value is going to look like this. True, false, okay? So I'm going to fill in, I'm sorry about that, that's a little bit outside my reach. I'm going to fill in these values here. Now remember, this is going to be an argument evaluation. So these are premises and this is our conclusion. And when I ask you, is this argument valid? What I really want you to tell me is whether or not the premises being true forces the conclusion to be true. Remember, validity is like the truth flowing from the premises right into the conclusion. So I'll show you in a second. That's true, false, and our conclusion, true, false. Now, I'm going to do individually negated statement letter here of this conditional. So I'm going to take a true statement and make it false, and I'm going to take a false statement and make it true. Now, the conditional, the only thing that I care about is the case where it's true and false, right? When that happens, the whole thing is false, otherwise it's true. Now, I am seeking to evaluate validity here. I'm asking you, is this argument valid? Right? That's what I'm asking you. And validity means it's not possible for the premises to be true and the conclusion false. So if I can find a case where I have true, false, then this is not a valid argument. Well, dun, 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 look right here. This line right here is a true premise and a false conclusion. So this argument is invalid, right? It is invalid. And so that's your answer. It's invalid. And again, if you want to add a little something to it, you can draw a happy face because we like valid arguments. The world would be a better place with more valid arguments. So there you go. That is problem number 12. It's a good way to start because you realize, oh, excuse me, invalid. Whew, we're not done yet. We have to write the all-important description. Don't do what I was about to do. Instead, make sure that you write the following statement to me. Invalid because there is a row on which the premises are true and the conclusion is false. Okay, so that is how your answer to number 12 will look. Next, we're going to take a little more complex one. We're going to work number 15 next. Okay, thanks. Good job. Okay, you guys, so this is problem number 15. We're almost done with our mock exam. Remember, this is an argument, and I want to determine whether or not it's valid. So first thing I want to do, remember, check your work, make sure that you wrote it down properly. So I'm going to check. I have A wedge, B implies C, that's fine. A and B implies not C, that's good. And our conclusion is B and not C. So essentially this thing is saying, if A wedge, B implies C is true, and if A and B implies not C is true, does that imply B and not C? So let's take a peek. Now I'm going to fast forward a little bit through this as I bring over my columns just to make it a little bit less tedious for you guys. So here we go. Okay, we wrote over all of our values. Remember, we're going to look for a row. We're going to see whether or not this argument is valid. In other words, is there a row where we have a premise that is true, true, and then a conclusion that's false? If we find that, then we know the argument is not valid. If we don't find it, then the argument is valid. Okay, so I'm going to work inside the bag first. So B implies C, so I'm looking for true, false. And if I find it, then I write false, otherwise I write true. Okay, now I have the wedge. So the wedge is very strong. I just need both sides to be false, and then the whole thing will be false. Otherwise, it's going to be true. So this is all true here. All right, now we're doing the conjunct here. Inside the bag, true, true is the only case where it's going to be true. Every other case is false. Okay, now we're going to do this column implies the negation of this column. So I'm going to do the negation first. It makes a true false and a false true. Just fire through there. Okay. Now, I know this is getting a little bit hairy for you guys to read, so I'm going to switch to a purple marker for this particular row. So I'm going to compare what I just finished here with what I just finished here under the conditional. If I see true, false, I'm going to write false. Otherwise, I'll just write the whole thing true later. Okay, true, false makes it, remember, true, false makes it false. True, true, don't care. False, false, don't care. False, 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 don't care. So, we have this one false and all the others are true. Okay? All right, so now I'm going to finish up over on the premises over here. So this one's bigger, it's more complex, but it's the same process, right? You're just applying the negation to individual statement letters. You have a couple more rows, but you're not doing anything differently. You're just basically writing down a couple more lines, really. And if you just go slow, it's fine. So this is the conjunct. Both sides have to be true in order for it to be true. So there are two instances of truth, and all the others are false. Okay, so we have a true here and a true here. All right, so we're going to assess this baby for validity. Remember, valid means that if these premises are true, it guarantees the conclusion. It means if the premises are true, it forces the conclusion to be true. If I find true, true, false, then the whole thing will be false. If I don't find it, it's valid. Or if I find true, true, false, then the whole thing will be invalid. If I don't find it, it's valid. Okay, true premise, false premise, we don't care. True premise, true conclusion. True premise, false conclusion. Here it is. Whoop, whoop, whoop. Okay, this third row down. I have a true premise because of the wedge. I have a true premise because, remember, the antecedent of this conditional right here is false. And then I have a big, huge conjunct of false, false, which is false. So I have a premise that's true, a premise that's true, and then a conclusion that's false. And so this is invalid because there is a row on which the premises are true and the conclusion false. I had to abbreviate it there because I'm running out of room, but you can see it's invalid because there is a row on which the premises are true, right here, and the conclusion is false, right here. And so if you think you're good, but then I would just bulk it up a little bit, right? Maybe make a sad face of some kind, just because we would rather have valid arguments. Okay, you guys, I hope that's helpful for you today. I'm going to try and squeeze out another problem set later.